In this video, we're going to continue practicing graphing sine and cosine functions with new amplitudes and periods and phase shifts, etc. So look, I have this a value right here of 6. And that a value tells me that the amplitude is going to be 6. Now, I've got this b value right here, and the b value is pi. Now, the b value indirectly gives us the period, because the period is always 2 pi divided by the b value. So that means the period is going to be 2 pi divided by pi, which means that the period is going to be 2. That is interesting. Now, nothing is being added or subtracted, so there is no phase shift. So I'm going to just go ahead and say none. This should be enough information for us to sketch this graph. So here we go. Because the amplitude is 6, I'm going to go up to positive 6, and I'm going to go down to negative 6. Because the period is 2, I'm going to come all the way over here and put a 2. That means if I go halfway, this should be simply 1. If I go half of that, this should be 1/2. And if I go between these two, it should be 3/2. Alright, 1/2, 2/2, 3/2. Okay, so this is a sine function. So that means it's going to start off at 0, at the midline. And then it's going to go up to its highest value, back down to the midline, down to its lowest value, and back to the midline. So since there's no phase shift, this is simply the final answer. Okay, let's go straight into number 26. This is the a value right here. That tells me that the amplitude is going to be 2. This is the b value right here. So the b value indirectly gives you the period, because the period is always 2 pi divided by the b value. So that means the period is going to be 2 pi divided by pi over 2. So that means that the period is 2 pi times 2 over pi. The way you divide by a fraction is you multiply by the reciprocal. So that's what I'm doing. But if I multiply these, notice that the pi will cancel out. I have this pi up high and this pi down low. These pi's are going to cancel each other out. That just leaves me with 2 times 2, which is 4. So the period is going to simply be 4. Notice it's not 4 pi, it's just 4. 4 radians. There is no phase shift. There's nothing that's being added or subtracted on the end. So for the phase shift, we're just going to say none. Now, this should be enough information for us to sketch the graph. Since the amplitude is 2, I'm going to go up to 2, and I'm going to go down to negative 2. Since the period is 4, I'm going to come all the way over here, and I'm going to put a 4. If I go halfway, that's going to be 2. If I go half of that, it's going to be 1. That means right here must be 3. Now, this is a cosine function. The cosine function starts out at its highest value, and then it falls down to the midline, this is going to be the final answer, so let me do this in blue. It's going to start off at its highest value, fall to the midline, and then it will drop to its lowest value, return to the midline, and end at its highest value at the end of the cycle. So this is the final answer. And that's it, since there's no phase shift or anything. Alright, these graphs are going much quicker than the other ones did. Let's see if our luck holds. So looking at number 27, here is our A value right here. That tells us that the amplitude is 1/2. This is our B value. Alright, everything here in front of the X is the B value. Now that will indirectly give us the period, again, because the period is always 2 pi divided by the B value. So the period is going to be 2 pi divided by 2 pi. So the period is going to be 1 radian, not pi, 1. And there is no phase shift. Nothing's being added or subtracted on the end. So this should be enough for us to do the graph. Okay, phase shift, none. So the amplitude is 1/2. So that means I'm going to go up to positive 1/2, and I'm going to go down to negative 1/2. Since the period is 1, over here I'm going to put 1 at the end. Then if I go right in the middle, this should be 1/2. If I go half of a half, that is 1/4. And if I go here, this should be 3 times 1/4, so this will be 3/4. So this is a sine function. So the sine function is going to start at 0, and then it's going to go up to its highest value, fall to the midline, drop to its lowest value, and back to the midline. So this is what the final answer should look like. Okay, let's keep going. Alright, now we're getting back to the more challenging problems again. Before I can really even read this graph properly, this equation, I have to be careful. I have a B value, and then I have some type of a phase shift. But guess what? The phase shift will not be pi over 2. I have to factor out the 3. So remember, it works like this. If I take my 3x minus pi over 2, before I read the phase shift, I have to pull that 3 outside of parentheses. I have to factor it out. And when you factor something out, to find out what goes inside the parentheses, you must divide. So that's going to leave me with x minus. So the question is, what is pi over 2 divided by 3? Now when you take a fraction and you divide by a number, all you are really doing is you're putting that number in the denominator. So this is really going to be pi over 2 times 3, or pi over 6. Alright, so pi over 2 divided by 3 is pi over 6. Okay, so this is really the phase shift, pi over 6, not pi over 2. So let's rewrite the equation in this form. So I now see that I have y equals 5 times the sine of Now inside of here I'm going to put this. So I have 3 times x minus pi over 6. Okay, now I can read what's actually going on. So this is my A value right here. So the amplitude is going to be 5. This is my B value. So that will indirectly give me the period. The period is always 2 pi divided by that B value. So that's why the period is going to be 2 pi divided by 3, because the B value is 3. Alright, so the period is 2 pi over 3. Now the phase shift is pi over 6. Not pi over 2, pi over 6. And because it is minus pi over 6, this is actually going to be a shift to the right. It's the opposite of what you might normally think. So this should be enough information for us to draw the graph. Okay. Since the amplitude is 5, that means we will go up 5 and we will go down to -5. Since the period is 2 pi over 3, I'm going to put 2 pi over 3 way over here. So this would be the end of one repetition of the graph at 2 pi over 3. If I go halfway, though, if this is 2 pi over 3, this should be 1 pi over 3. And if I go half of that, this should be pi over 6. Alright, now the third position should be 3 times the first position. Alright, so in other words, this is 1 pi over 6, 2 pi over 6. This should be 3 pi over 6. But this reduces down to pi over 2, because 3 goes into 6 twice. So this reduces down to pi over 2. So look, if there was no phase shift, let's look and see what the graph would look like. This is a sine function, and we know that a sine function starts at the midline, and then it goes up to its highest point, goes back to the midline, falls to its lowest point, and goes back to the midline. So this is what the graph would look like if there was no phase shift. However, there is a phase shift of pi over 6 to the right. Now notice that pi over 6 is right here listed among our values on the x-axis. That is useful because that lets you know that this distance is a distance of pi over 6. In other words, pi over 6 is one space, one jump on this scale. So when I say I'm going to shift pi over 6 to the right, that's going to be easy because it means I'm going to move each one of these points one space over to the right. So I'm going to show that in blue. So I'll start with the very first point always. If I move this pi over 6 to the right, it's going to land right here. Now the rest of the points should follow the pattern. But you know what, let me put another mark on here so I have somewhere to put this point. Okay, so this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Alright, so here I go. This point lands here. Now I'm just going to follow the rest of the sine pattern after that. Up to its highest point, back to the midline. Down to its lowest point, back to the midline. So this is what the final graph should look like. And there it is. But just for emphasis, please understand that I'm taking each point and I'm moving it pi over 6 to the right. So this point, for example, got moved to the right by pi over 6. This point right here moved to the right pi over 6. Same with this point and same with this point. I just moved each point over one space because each space is pi over 6 wide. And again, as we look at number 29, we have to be very careful. I see that we have a b value here, and then we have this number that's trying to be the phase shift. But guess what? Pi over 4 is not, I repeat, not the phase shift. The reason why, you have to factor the 1/2 outside of the parentheses before you read the phase shift. So look, if I have 1/2 x minus pi over 4. In order to read the phase shift, I need to pull this 1/2 outside of parentheses. To figure out what goes inside the parentheses, you have to divide. If I'm taking out 1/2, I have to divide each of these by 1/2. That way these will cancel out and I will just have x. Now, if you want to do pi over 4 divided by 1/2, okay, dividing by a fraction is the same thing as multiplying by the reciprocal. So pi over 4 divided by 1/2 is the same thing as pi over 4 times 2, or 2 over 1. So that would just give me 2 pi over 4, which reduces down to pi over 2. So that's what goes inside the parentheses. So if I did this division and I got pi over 2. So this will be x minus pi over 2. Okay, so I'm going to just rewrite this equation using this form. So that means I have y equals 3 cosine. Okay, but now on the inside of here, I'm going to put this. So on the inside of here, I have 1/2 parentheses x minus pi over 2. So x minus pi over 2. Okay, and this is the form we must use to judge the phase shift. Alright, so take a look. This is the A value. So that tells me that the amplitude is 3. This is the B value, the 1/2. That indirectly tells me the period, because the period is always 2 pi divided by the B value, which means that the period is 2 pi divided by 1/2. And when you divide by a fraction, that's the same thing as multiplying by the reciprocal. So that means that the period is 4 pi. So the period will be 4 pi. Now the phase shift is pi over 2, not pi over 4. We had to factor out the 1/2, and that left pi over 2. And it's the opposite of what you would think. So minus pi over 2 is actually a shift to the right by pi over 2. So this should be enough information to do the graph. Since the amplitude is 3, we're going to go up 3 and we're going to go down to negative 3. Since the period is 4 pi, we're going to come all the way over here and put our 4 pi. Then we'll go halfway, and that would be 2 pi. Then we'll go half of that, and that's just going to be pi, which means that right here should be 3 pi. Now, we're going to have a phase shift to the right, but we'll save that for later. Let's look at what the graph would look like without the phase shift. So this is a cosine function. And a cosine function will start at its highest value, and then fall to the midline, and then go to its lowest value, back to the midline, and then end the period at its highest value. So this is what the function would look like with no phase shift. However, because there is a phase shift of pi over 2 to the right, I need to move each one of these 5 values to the right by pi over 2. Now, where is pi over 2? Pi over 2 is half of pi. So pi over 2 would be right here in the middle. So in fact, this is going to be just pi over 2. Now, that means each one of these points is going to be shifted over half of a unit. So it'll be like this will come here. Alright? This will shift to here. The 3 pi will shift to here. Anything at 4 pi will shift to here. So in each case, I'm taking whatever I had and I'm adding pi over 2. So look, because this is right in the middle, I really could just count. So this is 1 pi over 2. So this would be 2 pi over 2. And this would be 3 pi over 2. And this would be 4 pi over 2. And this would be 5 pi over 2. And this would be 6 pi over 2. And this would be 7 pi over 2. And this would be 8 pi over 2. And this would be 9 pi over 2. So these green marks are where my points will land after I shift to the right by pi over 2. So I'm going to take each one of these pink points and I'm going to shift them pi over 2 to the right. So really just focus on the first point. If I shift this over pi over 2, it's going to land right above here. The rest of the values, I can just follow the pattern of cosine. I can fall down to the midline, making sure I'm using the green mark. And then I'm going to fall to its lowest value, again lining up with my new green mark. And then back to the midline at the green mark. And then to its highest value above the green mark. So these blue points represent the final graph. Okay, now just for emphasis, remember that I'm really, if you look at this, the pink points, those critical values, in each case I am shifting them. Each one of them got shifted pi over 2 to the right. And that's how we got the new graph. Alright, that's what phase shift means. Okay, I know this video is getting a little bit long, but we only have one more problem, so I'm going to squeeze it in here. Alright, be careful with this equation. One more time. Whenever you have a b value, and you're trying to see a phase shift, you see that a phase shift is coming. You have to be careful because pi over 6 is not the phase shift. You cannot read the phase shift until you factor out the b value outside of the parentheses. So look at this. I have 1/3 x plus pi over 6. Now, in order to read the phase shift, I have to take this 1/3 and factor it outside of parentheses. I can do that if I divide both of these terms by the 1/3 that I'm pulling out. So I have to divide by 1/3. Okay, that way these are going to cancel out and I'm just going to have x. So I've got pi over 6 divided by 1/3. Well, dividing by 1/3 is the same thing as multiplying by 3. Alright, you multiply by the reciprocal. Okay, so this is like having 3 pi over 6. 3 goes into 6 twice, so this is pi over 2. So I will have x plus pi over 2. And this is the real phase shift. So just be careful. So when I create my function in a moment, I'm going to rewrite this part as 1/3 and then just like I have right here, I'm going to have x plus pi over 2. And this is where I will look for the phase shift. Okay, so I will write the rest of this. So I have y equals -5 cosine, and then the rest of it in the way that I've rewritten them. So now I am ready to look and see what I have. So this is my a value right here, that -5. That tells me that the amplitude is 5. The amplitude is always positive. This 1/3 is the b value. That indirectly tells me the period, because the period is always 2 pi divided by that b value. So the period is going to be 2 pi divided by 1/3. Okay, dividing by 1/3 is the same thing as multiplying by 3. So the period is going to be 6 pi. Okay, so the period is 6 pi. The phase shift is not pi over 6. Again, I have to look at this form. The phase shift is pi over 2. And the direction is the opposite of what you might think. Plus pi over 2 is actually a shift to the left by pi over 2. This should be enough information for us to draw the graph. Alright, since the amplitude is 5, I am going to go up to 5 and I'm going to go down to -5. Since the period is 6 pi, I'm going to go over here to 6 pi and put 6 pi. If I go halfway, that should be 3 pi. If I go half of that, that should be 3 pi divided by 2, 3 pi over 2. What about this? This third position should always be 3 times the first amount. So in other words, if I do 3 times 3 pi over 2, that's what should go right here. But that is 9 pi over 2. So that's exactly what I'm going to put right here, 9 pi over 2. Okay, now let's save the phase shift for last. Let's think about what the graph would look like without a phase shift. Now this is a cosine function. So normally the cosine function will start off at its highest value and then fall like a U. However, this negative sign in the very front means a reflection over the x-axis. So this should be upside down. So instead of starting out the highest value, my cosine will start at the lowest value. And then it will go up to the midline, and then rise to its highest point, fall back to the midline, and end again at its lowest point. So this is what the graph would look like without a phase shift. But I need to move all of these points to the left by pi over 2. Now this gap right here is 3 pi over 2. I'm shifting them to the left by 1 pi over 2. So they should be moving a third of a space over. So I'm going to mark these in green so you can see them clearly. So each one of these points is just going to move just a third of a space over to the left. So like this. So every mark that you see, I'm moving a little bit to the left of that. All right, it's a little bit to the left of every critical value. Now, what's very important is that we label these accurately. You will be graded heavily on how well you label these shifted critical numbers. The first one is easy. It's pi over 2 to the left, so the first one will simply be negative pi over 2. Now for the rest of these, you could subtract. Now this one is still pretty easy because I have 3 pi over 2 minus 1 pi over 2. So that should be 2 pi over 2, which is just pi. Alright, so I'm doing 3 minus 1 and then reducing. So this should be pi right here. Okay, what about the next one though? So the next mark is to the left of 3 pi. So the question is, what is 3 pi minus pi over 2? Well, we need like denominators. So imagine that we multiplied the numerator and denominator by 2. That would give us 6 pi over 2 minus 1 pi over 2. That's going to be 5 pi over 2. So that's the value that I have marked here. So this will be 5 pi over 2. Alright, the next one is going to be relatively easy because the next critical value is at 9 pi over 2. So you can do that in your head. If I have 9 pi over 2 and I'm taking away 1 pi over 2, shouldn't that be 8 pi over 2? But doesn't this reduce down to simply 4 pi? Okay, 8 divided by 2 is 4. So this value right here should be 4 pi. Alright, that wasn't too bad. Now last one right here. This is to the left of 6 pi. So the question is, what is 6 pi? And if I'm moving to the left by pi over 2, then I'm subtracting pi over 2. But I need like denominators. So let's multiply by 2's. So this would be the same thing as having 12 pi over 2. So I have 12 pi over 2 minus 1 pi over 2. Wouldn't that be 11 pi over 2? So that's what this will be right here. It will be 11 pi over 2. So it's time to do the actual phase shift now. So I'm going to take each of these pink values and I'm going to shift them to the left by pi over 2. And I've already put the green mark to show exactly where they should land. So focus on the first point. That's the most important. If I take this and I shift it to the left by pi over 2, it's going to land right here. So each one of these points is just going to shift a little bit to the left. Okay, just line them up with the green marks that we made. Alright, so can you see I just moved each one of them to the left a little bit, and I already have their locations marked in green. So this should be the final answer. Okay, that is what this graph should look like.